Good morning, General Math, and welcome to week 5. To find week 5, scroll down to week 5, and you'll have your assignments all listed here. So you got some materials for you to review. You got your first worksheet, which is proportion triangles. You have some repetition work with the PowerPoint and fill in the Word document. You're going to have a second worksheet with percent and proportions, and then you just have a question to answer. So proportions are used a lot in engineering practices, and it usually starts by creating some kind of model. So this is a toy car, but if you're actually a company that designs new cars, you would actually start with a model. And what would you do later is actually, after you get all the correct dimensions of the model, you would just expand that to make a bigger version using the same dimensions you have in your model. Now, the biggest example I've seen in movies is actually with Zoolander. So in the movie Zoolander, the main character is presented with a building that is going to be created for children who don't read well. And of course, it's a model. He doesn't really understand that.
What is this? A center for ants? What? How can we be expected to teach children to learn how to read if they can't even fit inside the building? Hear your excuses! The center has to be at least 3 times bigger than this.
Obviously, the center would probably have to be more than 3 times bigger than that. But you get the idea. The whole idea is that proportions usually use models, and then you expand it and make it bigger or smaller depending on what you need. So when I was younger and in grade school, we actually had to learn how to read maps and using inches or centimeters and converting them to how many miles something is. So this would be the scales: 1 inch equals 4 miles. So what if it was 2 inches? How many miles would that be? 3 inches, how many miles would that be? That is another good example of proportion and scales and how to change them, make them bigger and smaller. And again, what if I said it half an inch? How much is half an inch? So if your 1 inch equals 4 miles, how much would be half an inch? Now in your head, you could easily say 2. You just divide 2. Okay. But again, it is a skill that is used. Now, if you're like, Brizik, I'm probably never going to use a map, you never know that. It's a skill that's worth having. Why not have it? I am going to go over some examples with you using poster paper just to see, so you could get the idea of how I would like you to solve it. But then again, if you feel like you could look it up on your own, there are tons of YouTube videos showing you how to use cross multiplication to figure out proportions and scales. So first, what I'm going to do is actually go over how to solve these kind of problems. So if you're with me to this point, then this is actually the first question from one of the worksheets about proportions. And what I did specifically is that I made the numbers and the missing term, these two, the same. Because remember, what we're doing is we're taking this triangle and we're just making it bigger. So everything in proportion-wise should be the same. So what I did is that since this, we know this, I made this black and I made the missing variable black. And I'm going to show you why, because when we do cross multiplication, it helps make sure you're aligned up properly. And I made this red. So how do we set this problem up? Well, I'm going to first take these two numbers. So I'm going to take 8 over 6 hopefully that you can see that. And I'm going to take x over 18. Now, how cross multiplying works is that I'm going to take 8 and I'm going to multiply it by 18, and then I'm going to divide it by 6. So it makes this kind of junk, divided by 6, and then that's going to give you x. So again, 8 times 18 divided by 6. So when you actually plug this into a calculator, the number you get is 24. So your x is 24. Now another thing you could do is, if you know that something times 6 equals 18. So if I looked at this, I'm like, well, 6 times 3 equals 18. Then that means if it's proportional, that means 8 times 3 has to be x. And I could also check. 8 times 3 is 24. That makes sense. So if we wanted to take this triangle and make it bigger with keeping this proportional, it would just be multiplying this number by 3, this number by 3, and then whatever this side is, we don't know. But if we did, it would also be multiplied by 3 to make it proportionally bigger. Now I do want to let you all know that for this, you actually have 2 pages. The second page is completely optional. And what it basically means is that if I were to make this triangle 2/3 larger, what would it look like? And then actually you do the exact same. Use my office hours and we could go through it together. Just remember, you got to do the first page. So the next thing I'm going to do is do some problems, 2 problems from the percent and proportions worksheet. It's a warm-up, and I'm going to show you how to do 2 of these problems. I'm going to do 1 and 2. So there's 9 questions for you. So if you do the first page of the shapes, proportions, do this independent practice, and just make sure you answer the question and do the PowerPoint, you are done with this week. So let me show you how to do the proportion problems. Okay, so we have the first problem. Now, the problem states that on a map, 4 centimeters equals 30 kilometers. So we're trying to see is if city A and B are 75 kilometers apart, how far apart are they on the map? So how many centimeters are they apart? A really important thing to keep in mind is make sure that you have your units lined up. So you know that this is going to be centimeters. I actually kind of like to set it up like this first, so I know what I'm looking for. And I also always like to put the missing variable on top. That's just a preference of mine. You can work it however you want. So what I'm going to put is our missing variable on top. So how many centimeters? And then I'll put the centimeters on the same side. That's just how I like to do it. So, and then over here it's going to be 30 kilometers and 75. Oops, I actually got to switch those. So I actually made a mistake, and I'm going to make hopefully you don't make the same mistake I did. So remember that 4 centimeters is 30 km. So we got to make sure that the 4 and the 30 are in the same part in the fraction. And this question mark is 75 kilometers. So the process is like usual. We cross multiply. So it's going to be 4 times 75 and then divided by 30. Now another hint that will kind of help you make sure you get the number in the right ballpark is that if 4 centimeters is 30 kilometers, you know that this number is going to be bigger since 75 is bigger than 30. And it's almost double, a little bit more than double. So let's see. So I laid out my equation. 4 centimeters times 75 kilometers divided by 30 kilometers. And actually the kilometers itself, the units would cross out. So after I do all of this, the answer is 10 centimeters. Which makes sense because this 10 centimeters is about 2.5 more than 4, and 75 is about 2.5 more than 30. So it makes sense. So that would be your answer for question 1. So question 2 of this worksheet is, if a 50-foot flagpole casts a 95-foot shadow, then how long is the shadow that a 5-foot man casts? So what I did is I took the flagpole and I put it over here. A 50-foot flagpole means a 90-foot shadow. Now we have a 5-foot man, so how long is the shadow? Now if you kind of could see, the shadow is longer than the height of the flagpole. That's something to keep in mind when working on this. Meaning whatever this number is, it's going to be bigger than 5 feet. So when I set up my fractions, I have to make sure that the flagpole and the 5-foot man are on the same part of the fraction. It doesn't matter if they're both on top and you put your unknown variable on the bottom, it just needs to be in the same spot. So if my 5-foot man is here, then my flagpole needs to be on the bottom as well. 50 feet. And flagpole. I like to also make sure flagpole. And then on the top, it's going to be 95 feet shadow. So again, I'm going to cross multiply. I'm going to take 5 times 95. 5 feet times 95. And I'm going to divide it by 50. And when I do all of that, my answer is 9.5 foot shadow. So my missing variable is 9.5. So that's as much as I'm going to do. If you have any questions, you need to make sure to sign up for office hours, email me, figure out some way, but please don't wait to the last minute and not do your work. It's really important to stay up to date and be prepared for whatever your future has with the general math knowledge you can acquire. Thanks. Bye.